Sleep wake up. That is for the last topic that we discussed. Let me recap the third characteristic of CAN. The CAN has that is error detection and fault confinement. A detection of error has been implemented in hardware itself, in peripheral itself. Also, how to handle error, that is also designed in the hardware itself. How the fault detection and fault handling works in Kano. It is very simple. If you have 4 nodes in a network, each node used to have 2 counters. They used to call those counter as TX error count and RX error count. There are 2 types of error counter maintained in every ECUs. Those are connected in the network. There are some nearly 12 rules we have. It is specified in the CAN spec. If any of those 12 rules is met, they will increment the error counter of those 12 conditions are fault condition. That means those are the error condition. Any one of those 12 condition occur, they will modify the error counter. Depends on if the error is occurring in a transmission means they will increment the TX error count. If the error occur in reception means they will increment RX error counter. These 2 error counters are maintained in every ECUs. Again, this error counter that they maintain in each ECU, those error counters are not simply an up counter. What does mean by up counter? Simply it used to increment one after another. Again, it is not a proportional counter. Proportional counter means 1 after 2, 2 after 3. That is a proportionally increasing error count. But it is not like that. In case of CAN, those error counter, those are maintained in the ECU, used to increment sometimes by 8, sometimes by 1. Sometimes they used to decrement by 8, sometimes they used to decrement by 1. The increment as well as decrement, both are not proportional. They are not simply up counter. It used to increment and decrement. There is like fluctuation of that is increment, decrement, like that it used to go. Errors which happens in the transmission of CAN packet is monitored and captured in the transmit error count. The error happens in the reception is maintained in the RX error count. But though after these incrementation and decrementation, sometimes the accumulated error, it used to cross certain threshold. The threshold is 128. When your error counter is less than 128, it's okay. They used to call that as an active error. In that case, they used to transmit error frames to denote that there is an error. Each ECUs are updating their error status in 2 ways. One way is the moment they find out an error, they will update their error count. That is maintained inside the ECU that we cannot see. We cannot see that in the bus. Another one is they will transmit an error frame. Error frame is a fixed structure frame that we are going to see after this in upcoming slide. In that fixed format frame, that will be transmitted to the bus to indicate that there is an error. They are updating their error count internally as well as they are publishing there is an error by means of transmitting error frame. These 2 things will happen for every transmission error and reception error. When they are crossing, sometimes when the accumulated error crosses 128, then it will go to the second level. That means it is somehow severe. After the second level, again, your accumulated error crosses 256, then that's all, halas. Everything is over. After that, they will, that ECU, which is having such a error count, it will automatically turn it off by itself. So it won't do any CAN transmission. It won't participate in the network. It will go and will be in a state called bus off for the period of nearly 2 hours. After 2 hours, it will wake up and will try to transmit again. If it finds the problem again it will go to the bus off state after moving all these stages, stage 1, stage 2, and then bus off, like that. This process will repeat as long as you connect with the battery. As long as there is a battery connection, this sequence will repeat. This is the process in which they are updating the error, and then they are handling this. You don't think that the bus will command some ECU to turn off his message. No. In CAN, no node will command other node to turn off his message. That is not possible because the CAN follows CSMA method. So no one can command another node to turn its message off or something like that. Then how this happens? It's all like every ECUs internally, they, based on this error counter, they turn them off or they turn them on. Like they are pushing them to bus off or they are making them to available for the bus, and then they will continue the transmission. All these things happens. So don't think that one node will command another node. No, not like that. There is no master. There is no master and slave concept in CAN. Every node is the master. Is that clear? How the error deduction and then the error handling works in CAN? Do you understand?
Yes.
How the error is handled in the CAN?
I know that the types of error, active error, passive error, and the bus off. If the error goes to greater than 127 means it's an active error, and greater than 128 it's a passive error, and if it's 258 that means it's bus off. So these are the concepts I understood so far.
Okay, brilliant, yes. Brilliant. Let me ask you one question. Yes. When the error count is 128, how that error count is updated in the CAN bus? Will that one issue will ask another issue to update its error count, or how that error count update happens? So what you told is correct. If the error count is less than 128, it is active error. What is error count? Where it is maintained? Who updates that? When the error count is less than 128, the node will be in active error. When the error count is greater than 128 and less than 256, it will be passive error. When it crosses the 256, it is bus off. Like that she says. First of all, is that correct? And then, if that is the case, from where they are getting that error count, how it is updated, who updates that, based on what they are updating it? That is my question.
The statement is correct actually. So the transmitter, okay. Transmitter updates the error count.
So you mean to say the receiver will not update the error count?
Yeah, receiver, once it receives, then only we can, based on the CRC code, always it verifies. Okay, whenever it unmatches, so it is an error.
Okay. Based on your second statement, you are seeing like there is a possibility of reception error as well. If that is the case, yes. Where they maintain those error count? What you told is the error counts are updated by the transmitter. That is your first statement. In the second statement, you are also saying the receiver also has the possibility of getting errors. If that is the case,
I think it
what
is
will
the end
happen?
of the frame. We have the 6 or 7 bits. Maybe in that it is going to update.
Okay, okay. Could you explain what are that? Because this is somehow very important. If you have confusion in that, the entire thing you won't understand it at all. That's why I am insisting I am asking you whether you understand or not. Yes, please go on.
Internally, they will maintain the error counters.
Okay. In which?
In the ECU.
In every ECU or only one big ECU?
In every ECU, they used to maintain internally error counter.
How many error counter? Okay, you say error count. Is it only single error counter or it is 2 error counter? Actually, there are two
error counters.
2 error counter. There are 2 error counter. What are those? What are those?
Yes, transmission error counters and the receiver error counters.
Brilliant, brilliant. Now you people are thinking. Actually, every ECUs in the network has 2 error counter. When there is a problem in the transmission side, they will update the transmission error count. When there is a problem in the reception side, they will update the receive error count. These 2 error counts are only used to say like active error or passive error or bus of all those decisions are made only based on these error counter. These error counter, you cannot see them in the CAN signal or CAN frame. No, they are maintained internally in every ECUs. Why they are only monitoring about the transmission and reception error? What about the other errors? Those are all like diagnostic related errors. They won't bother about that. This error count, those are used for active error, passive error. Those are purely the communication error. They are not like a ECU error or ECU fault memory error or ECU sensor failure error. No, they are not for that. The errors that we are talking about is only the communication error. Those errors are only used to migrate from one state to another state. From active error to passive error and passive error to bus off, like that. Do you understand that? Are you clear about what we are explaining now?
Yeah, sir. Yeah, I'm clear.
What you understand?
Understand transmitter error count and receiver error count overall count only for due to communication. It's not what to say.
It is
It's
not a
all about
ECU
yeah.
internal
It's all
fault.
it is all about only communication error.
Brilliant, brilliant, super.
Yeah.
Super. Okay, that is what the thing. Based on these error counter only, this active error, passive error, and bus off, those decisions are made. How they will update it? Okay, this is one question. You told they are maintaining internally 2 error counter. How they will update? There should be an increment and decrement. No. So when you say crossing 255, then when we say something, it is crossing or it is greater than, if that is the case, that error counter is updated. How it is updated? Based on what it is updated?
There might be any algorithm.
Actually, there are 12 rules. It is specified in the CAN specs. Most of them are communication related. We will see those 12 rules also. Those 12 rules are used to increment or decrement. So it is not like always incrementing. The error used to increment always. No, sometimes it used to increment, sometimes it used to decrement. When there is a positive, you are able to do and successful transmission. After a failure, it used to decrement. But the very first time you are attempting to transmit, you are getting a failure, it used to increment the counter. It is like an up-down counter. It used to increment sometimes it used to decrement. But when accumulated error crosses this threshold, then only the problem will happen. Okay, let me tell you one example for this. A bank is providing loan to a person. I am getting the loan, assume, for my business. Initially, I went to the bank and asked some 10 lakhs loan. Okay, they gave 10 lakhs. But what I did after buying 10 lakhs, I am giving only 5 lakhs back. But after giving 5 lakhs, I am asking another some 10 lakhs. I don't know whether they will give or not. I'm just saying. So after giving 5 lakhs, I am getting I'm asking for another 10 lakhs. Totally, how much I have to pay? How much I owe to the bank? See, initially I got 10 lakhs, man, and then I returned back 5 lakhs. Then I again got 10 lakhs. What will happen? What is the accumulated debt that I have?
15 lakhs.
Okay, 15 lakhs. After that, I am only giving back 2 lakhs. Then what is my accumulated debt? 13. After that, I am getting again one more 5 lakhs. What is my accumulated debt now? 18. See, sometimes I'm getting, sometimes I'm giving back. But the rate in which I give back, that is very less than rate in which I getting the loan. Amount of money that I am getting from the bank is higher than the amount in which that I am returning back. Whatever that I am getting from the bank, you assume that as an error, a transmission error or a reception error, which is incrementing. When there is a successful transmission after a failure, you consider that as like you are returning back whatever that you return back to the bank, like that. When you are trying to transmit, you are getting error, and then after some time you are able to transmit, again you are facing the error. So when this cycle repeats, when the amount of error that you get for transmission or reception, accumulated error count exceed, otherwise they used to call it average error count. When it crosses the threshold of 128 or 256, then only they will enter into bus off. Do you understand what I'm trying to say?
Yeah, yes.